One of the many ways in which the Maya were ahead of their time was in their creation of what we would refer to as zero.
With a simple combination of a shell which represented 0 or completion, and then a dot, number 1, and then a 5. By just placing them in different positions, they were able to multiply, and reach incredible numbers.
The Greeks and Romans were tremendous engineers, theologians, historians, and so forth, but were very limited by their mathematical system because they didn't have a zero. So here you have the irony that they were able to produce great public works, philosophy, and whatnot, but are really pretty lousy mathematicians compared to the Maya.
Khan Balaam's engineers' advanced mathematical observations may have included the discovery of proportions like the square roots of rectangles and something called the golden mean, a naturally occurring proportion that can be seen in animals, nature, and even the human body as 1 to 1.618.
Measure a person from his head to his belly button, and then from his belly button to his feet, you get a proportion very close to 1 to 1.618, the golden mean.
Some scholars believe this proportion has been appearing in structures for thousands of years at places like the pyramids of Giza in Egypt and the Parthenon in Greece. Da Vinci's Vitruvian Man is a study of this proportion, and some even say he painted the Mona Lisa using this ratio in her features.
So now we're going to try a little Mayan arithmetic. And so we have two different Mayan numbers here, and we're going to try to add them. So notice that we have two different position values here, so I'm going to go ahead and, just for the sake of clarity, divide them up. So these down here are our ones places, and on the top are our fives places. Now, if we were just to literally add these, we can imagine that we would add the dots and add our dots in our lines here, which would be 1, 2, 3, 4 lines, 1, 2, 3, 4 lines, and 1, 2, 3, 4, 5, 6 dots. 1, 2, 3, 4, 5, 6 dots. But of course, we're not supposed to have 6 dots, right? We're only supposed to have at most 4 dots. So we're going to have to do a little bit of shifting here. Now, the first thing that we're going to do is we're going to take these 4 lines here, because we're not supposed to have 4 lines either, because what's 4 lines? 4 lines is 20, and 20 is more than can fit in the place value, so this has to get carried up here as one more 20. And so we're going to have 1, 2, 3 20s now, instead of just 2 20s. Now, we still have 1, 2, 3, 4, 5, 6 dots here, and that's not good, but we can group 1, 2, 3, 4, 5 of them, and those 5 dots can get converted into a line. So those 5 dots now are going to become a line, and so in our final addition, we're going to have a line and a dot. So that's our 5 and 1 more, 6 dots there, and then 3 20s. So we have 3 in the 20s place. Now, just for the fun of it, let's verify this by thinking in base 10. So this would have been 120 and 5, 10, 15, 16, 17 ones. So that's 20 plus 17 is 37. So this was the Mayan number for 37. Here we have 120 and 5, 6, 7, 8, 9 ones. So that'd be 20 plus 9 is 29. If we add in our normal base 10 system, 37 plus 29, we get 66. So let's make sure we got the same answer over here. So over here in our final answer, we had 3 now, 3 dots, each of which represents 20. So 3 times 20, and a line and a dot is 6 times 1. So 3 times 20 is 60. 6 times 1 is 60. Those add up to 66. And we have agreement, which means it looks like we actually added this right using our Mayan system. So notice there's a big similarity here between what we do in our base 10 system when we add, and when we add in the Mayan system. When we add up and we have more than will fit in the current space, in the current place value, we carry into the higher place value, and that's exactly what we did here with our Mayan numbers.